yeah.
Good morning. Many thanks for your kind invitation to speak to you today. These are my financial disclosures, and those in red apply today. I'm going to be speaking about AI and how it impacts various aspects of vision correction. Looking at the Spenticam, we think we have the all clear to do LASIK. Yet, looking at the Palern display, our opinion changes given the change in the BAD. This is all artificial intelligence. Let's look at ray tracing outcomes for LASIK. Irrespective of the procedure that you do, whether it's standard, wavefront optimized, wavefront guided, topo guided, or custom Q, the laser thinks you're treating Gould-Strand's eye model. Gould-Strand's eye model has an axial length of 24 millimeters and a corneal curvature of 43 diopters every time. The Wavelet OB820 allowed the lens to be visualized anterior surface and posterior surface. This gave us the power to develop models based on the patient's own eye. Instead of using a refraction, the wavefront is used. Instead of using an arbitrary 43 diopters, a pentacam is used with 24,000 data points. There's even information on the posterior surface as well as the anterior chamber depth and some information on the anterior aspects of the lens. Using the lens style biometry, we now have the exact data points along the central line of sight, and now the virtual eye can be developed. The AI component comes from the expected biomechanical response and the expected epithelial healing response based on a review of the literature. The results that we saw from this multi-center trial were the best that we had seen to date with LASIK. Inclusion criteria was myopic sphere equivalent of more than -4 or astigmatism of more than -2. This was the first time in my experience that I was involved with a study that got better outcomes than FDA studies. There are more than 20 different IOL power formulas. We know that none are 100% accurate. AI can significantly improve the accuracy of IOL power calculations. The HEAL RBF2 was the first commercial AI-based formula driven purely by data. The Hopper Q formula was further improved by adding Savini and Thoroni. Improvements occurred due to machine learning that identified a T factor with a new effective lens position predictor, including gender and more biometric data, and an axial length adjustment for eyes longer than 26 millimeters. Data can be entered for both eyes at the same time. There's a sphere equivalent, a toric, and a post-laser vision correction module. The Kane formula is based on large data sets from high-volume surgeons with a combination of theoretical optics, thin lens formulas, and big data techniques. And in 2020, a study showed that the Kane formula was more accurate than all formulas across all axial lengths. Data can be entered on both sides at the same time, non-toric, toric, and Kane is specifically powerful for keratoconus eyes. The Pearl DGS formula is from Damon Cottinell's group. It's post-operative spherical equivalent prediction using artificial intelligence and linear algorithms. It is a hybrid thick lens formula. There are two algorithms that improve the value of predicted or approximated data such as ELP, posterior corneal radius, and refractive index of various ocular segments. The Ladas super formula optimizes for 10 ranges of axial length, 10 ranges of keratometry, 10 ranges of AC depth, providing 1,000 points in a matrix. It is obvious that this cannot be replaced with a single A constant. It works well for all surgeons, whether you're low volume, medium volume, or high volume, increasing your predictability rate to 95%. The Ladas super formula was independently analyzed by multiple ophthalmic companies and concluded that it is the best and most accurate of any method. At the same time, includes stericity, post-LASIK. You can target one eye for emmetropia, one eye for reading. The message regarding AI and IOL power calculations is that AI significantly improves predictability and hence outcomes. A literature review on working distances shows three main learnings. We underestimate near visual needs. We use near vision more than we think. We read up closer than we think, and the reading and viewing distances vary during every 60-minute period. And we have such a choice of IOLs. How do we make the right choice of which lens to use for which patient if we don't know exactly what their needs are? We've got three choices: an interview or discussion, a questionnaire, or objective visual data. The interview is tried and tested, but it's very subjective and open to misinterpretation. Questionnaires add some value, especially with regards to personality types. But objective data collected over 36 hours in the patient's home and workspace is more than any interview or questionnaire can provide. This works by replacing the subjective assessment with the use of a monitor worn in your spectacles that gives visual behavior monitor measurements, including a personal defocus curve with working distances, ambient lighting, and the head position of the patient. The Viveo monitor objectively measures patient behavior and matches it to the performance properties of a range of IOLs to compare monofocal, bifocal, EDOF, and trifocal IOLs. In this case, a monofocal adds 45% of uncorrected vision for distance. When you do a bifocal, you add 19% in terms of reading. When you add an EDOF, you add 37%, so the mid-range is taken care of. With a trifocal, you add 50% functionality. This personal defocus curve is then compared to the lens that suits best, and it defaults to a generic monofocal, but then adds every IOL with a published defocus curve, mix and match solutions, blended vision solutions, and target offsets. And you can choose at which level of vision you want to compare. In this case, we can see the days over which data was collected. We can see a summary with the personal defocus curve and a matrix showing us where most of the time was spent for distance, intermediate and near, and also the lighting conditions. The software on the Lifestyle Match Index now defaults to a generic monofocal, in this case providing 28% uncorrected vision. The lens that adds the most value is a trifocal, adding 65% functionality. A non-diffractive EDOF with one eye at 0 and one at minus 0.75 adds 58% functionality. And in this patient specifically, blended vision with one eye at plano, one eye at minus 175 adds 56%. Using objective data obtained remotely, we can enhance patient satisfaction by selecting the right IOL for the right patient. It strengthens word-of-mouth referrals and increases patient satisfaction. Many thanks for your kind attention. I hope this talk has shown you how AI has the potential to increase patient satisfaction.